Welcome to our super fun science journey. Today we are asking the question, is matter around us pure? What does pure mean? In daily life, it means no adulteration, like milk without added water. Scientifically, pure means all constituent particles of a substance are chemically the same. For example, milk is actually a mixture of water, fat, and proteins, and thus not scientifically pure. A mixture consists of more than one kind of pure form of matter, known as a substance. A substance is a pure single form of matter that cannot be separated by physical processes. Quick examples of mixtures include seawater, soil, and air. This activity helps distinguish between homogeneous and heterogeneous mixtures. Groups A and B mixed copper sulfate in water, resulting in a uniform homogeneous mixture. Groups C and D mixed salt and potassium permanganate, resulting in physically distinct heterogeneous parts. A homogeneous mixture has a uniform composition, and its parts are not visible, like salt in water. A heterogeneous mixture has non-uniform compositions with physically distinct and visible parts, such as oil and water. A solution is a homogeneous mixture of two or more substances. It comprises a solvent, the larger part that dissolves, and a solute, the smaller part that is dissolved.
When salt dissolves in water, the red salt particles mix evenly with the green water particles, creating a homogeneous mix.
Properties of a solution include being a homogeneous mixture with particles smaller than 1 nanometer. They do not scatter light, are stable, and cannot be separated by filtration. Key terms for concentration calculation are saturated, unsaturated, and solubility. We use the mass by mass percentage formula to find the concentration, as shown in the brain teaser example. A suspension is a heterogeneous mixture where solute particles do not dissolve and remain suspended. Particles are visible, scatter light, and are unstable, settling down. A colloid is a heterogeneous mixture with uniformly spread particles too small to see, a strong Tyndall effect, and stable, non-settling particles. The Tyndall effect is the scattering of a beam of light. We can observe this in nature, such as sunlight passing through a dense forest canopy, or light shining through a small hole in a dark room showing dust particles. This table shows the various types of colloids based on the dispersed phase and the medium, with examples like fog, shaving cream, and milk. We use various techniques for separation. Evaporation separates dye from ink, leaving the non-volatile solute behind. Centrifugation, like getting cream from milk, forces denser particles to the bottom. A separating funnel separates immiscible liquids based on densities, such as oil from water. Additional cool techniques include sublimation and chromatography. Sublimation separates components, such as salt and ammonium chloride, where one changes directly from solid to gas. Chromatography, exemplified by dyes in black ink, separates components that travel at different speeds in a solvent. To separate gases from the air is compressed and cooled to form liquid air. This liquid air is then warmed up slowly, causing the gases to separate at different heights based on their boiling points. Change is constant. Physical change occurs without changing chemical composition, like melting ice. Chemical change involves one substance reacting with another to form a new substance, such as rusting iron or burning wood. Pure substances fall into two categories: elements and compounds. Elements are basic forms of matter that cannot be broken down, including metals, nonmetals, and metalloids. Compounds are substances made of two or more elements chemically combined in a fixed proportion, and their properties differ from the constituent elements. To summarize the classification of matter, pure substances consist of elements and compounds, while mixtures are divided into homogeneous and heterogeneous types. Let's review some separation methods. To separate butter from curd, we use centrifugation. Sublimation separates camphor from salt. Finally, in a world inundated with separate iron pins from sand, we use magnetism. Great job on the challenge.